Imagine standing in a bright laboratory where instead of just reading data, you actually see reality unfolding on a glowing screen. It may seem like a science fiction film, but this is happening right now in the world of quantum physics where scenes come alive. Scientists are working with machines so precise, they can see quantum particles as they shift and move like dancers on a glowing stage. These particles behave strangely when someone watches them, like actors reacting to an audience in a mysterious scene. This is called the observer effect, a wild idea that just by looking at something, you can change how it acts like magic in a mirror. Years of experiments confirmed this wasn't fantasy. Particles truly behave differently when watched, like characters aware of the camera. It felt like the universe was looking back, aware of every curious eye and reacting like a hidden actor in a mysterious set. Now, something incredible has happened, and it changes the entire story of quantum physics like a plot twist in a suspenseful film. Scientists using Google's advanced quantum processor have watched particles without disturbing them like filming a dream without waking it. In the past, observing a particle destroyed its wave function, collapsing its possibilities like breaking a sand sculpture in a museum. But researchers found a way using a superconducting quantum chip, cooled to near absolute zero, like freezing time in an icy scene. At such cold temperatures, even the tiniest touch ruins everything, yet this chip stayed calm, ready to capture reality in stillness. This chip was made for this sensitive job, built to function inside the delicate frozen stage like a spotlight that never overheats. By using quantum entanglement, where particles are connected across space, they observed movement without breaking the flow like silent cameras. They didn't just see the particles, they predicted their future as they moved, like tracking stars across a night sky canvas. The observer and the particle now share a kind of conversation, a quantum dialogue, like two actors improving a live play together. The lines between watcher and watched are now blurred, like reflections dancing on a calm lake. Rather than destroying the system, observation has become part of it, gently steering like a boat on a quiet river. This turns the old problem of disturbance into a powerful tool, transforming quantum research like switching from sketches to 3D film. What we once thought impossible, controlling particles while watching, is now being done with careful precision on a glowing stage. This breakthrough connects to Heisenberg's uncertainty principle from 1927, which said you can't know position and speed at once. That principle still holds, but now scientists can track a particle's path with stunning accuracy, as if following footprints in snow. We're moving from snapshots to live participation in the evolution of quantum worlds, from watching to shaping the story. Google's chip took 5 years to develop and was designed to communicate with particles, like a translator in a theater of atoms. At first, researchers thought it was a bug, but repetition proved it was a real effect, not a trick of the set. Dr. Orrell of MIT suggested it might be a new law of physics that only appears when observation is constant like light revealing a stage. Dr. Eric Lindstrom of Caltech thought differently. Maybe the system is adjusting to our presence like scenery shifting for the viewer. This could mean new hidden dimensions, unseen layers that appear only when the light of observation hits the right angle. Reality might be layered like an onion, and we're peeling back the surface with each controlled experiment. It's like shining a flashlight into a cave and finding secret tunnels beyond the known scene. Not everyone agrees. Skeptics think it might be just a glitch in the chip, not a deep truth from the quantum stage. But researchers repeated the results using other platforms like trapped ions and photonic systems like switching sets in a science show. And they found the same effects, proving it's not just hardware, it's something universal, like a story told on every screen. One reason for this success is the use of AI, deep learning systems trained on quantum data that guide the live action. Google's AI adjusted in real time, rewriting its own rules like a director changing scenes mid-film. Scientists now call this ability quantum intuition, a kind of learning that goes beyond prediction, like sensing plot twists before they come. Dr. Alina Zhou of Stanford said the AI county evolved with the quantum system. It didn't just react, it shaped the narrative. This AI spotted patterns invisible to humans, becoming a partner in discovery, not just a tool on the set. Think about an AI that finds medicines by testing molecules that haven't even been created yet, like imagining costumes before writing the script. Or a system that updates climate predictions hour by hour, adjusting to real-time scenes on Earth. This is the beginning of a transformation where we're not just users but co-creators of science's evolving plot. Yet with great power comes serious questions. What is our role if AI outsmarts us in controlling quantum systems? Experts say we remain guides, setting the questions and paths while AI helps find answers like a writer working with a fast-thinking editor. Dr. Ellen Harper warns that these new minds must follow rules. We must set boundaries like borders on a stage. Despite risks, the potential is thrilling. Small labs can now compete with big tech, making science more open like new seats in a packed theater. These systems might solve challenges like climate change, mental health, and the mystery of dark matter, like writing new chapters in nature's script. It's more than a new computer. It's the dawn of a new scientific age where each click shapes the cosmic scene. We're no longer bystanders, we're part of the action, writing the path as we watch and measure and dream under the cosmic lights. Google's quantum core didn't just observe, it changed the very meaning of watching in science, like flipping a camera around. Now, the observer is part of the show, helping build the scene, guiding the next frame of the film. As we step further into this strange quantum world, we're not just discovering particles, we're finding new ways of learning and being. And this is just the beginning. AI and quantum machines together will uncover laws, create tech, and expand how we understand reality. What we thought were limits are now doors to deeper exploration, opportunities hidden just off-screen in the scene. The frontier isn't in space or time, it's in how we choose to see, think, and interact with the very fabric of existence. Subscribe to our channel and thanks for watching.